3.4 is linear programming. Now this one sounds like it's going to be a difficult lesson, but it's going to be very similar to 3.3, solving systems of linear inequalities. But the only difference, there's one additional step that we need to take a look at. So the direction says, graph each system of constraints, name all the vertices, then find the maximum or minimum the objective function. So they'll give you a system of inequalities. You're going to need to graph them. So I graphed them over here. So this first one, I started at 3. 1, 2, 3 is my y-intercept. My slope is -1, down 1 over 1, down 1 over 1. My next one is y is less than or equal to -1/2 x plus 2. So I started at 2, then I went down 1 over 2, down 1 over 2. X equals 0 is just a vertical line at 0, and y equals 0 is a horizontal line at 0. Now what I'm looking for is where all of them overlap. So if I take a look at my shading, this first one, it was less than it, so I should hit below. The second one, it's less than it, so I should below. It's greater than this vertical line, so I shade to the right of it. And then this horizontal line, it's greater than it, so I shade above it. So this part right here is where they all overlap. Okay, and in this section, they're always going to make a object that is bounded on all sides. So that will be a helpful way to remember where to shade. So then from here, I'm going to label those vertices of this figure. So it's 0, 0, 0, 2, over 2, up 1, so 2, 1, and then 3, 0. So I label those coordinates. And then they're going to give you an objective function. Okay, and you're going to plug in your x's and your y's into this equation. And then simplify them down. So I did that. I got 0 plus 0 is 0. 0 plus 6 is 6. -12 plus 0 is -12, -8 plus 3 is -5. And then I'm looking at these numbers over here now, and I need to find the maximum and the minimum. So my minimum would be this -12, and that vertex 3, 0 gave it to us. And then my maximum is 6, and that 0, 2 gave us that. Now let's try one more example. So again, I start off with graphing them. I want to try to find my bounded object. So I go to 4. My slope is -1, so down 1 over 1, down 1 over 1. And then I make that line. It's less than, so I shade everything below it. This next one, I start at 2. My slope is -1/3, so down 1 over 3, down 1 over 3. It's less than, so I shade below it. I have x is greater than 0, so that's that vertical line. I shade to the right of it. And y is greater than or equals to, so I make that horizontal line at 0, and I shade everything above it. So it's this object right here. So I label all 4 of those vertices. So 0, 0, 0, 2. I have 4, 0, and 3, 1. So I label all of those, and then I have my objective function. Then I'm going to plug these coordinates right into this equation. If I have 4 vertices, I should be plugging in 4 coordinates. If I would have 5 vertices, I'm plugging in 5 different coordinates. And then I simplify them down. And when I do that, I get 0, 6, 9, and 8. Now I'm looking at these numbers to find my minimum and maximum. So 0 would be my minimum, and 0, 0 gave us that. And 9 would be my maximum, and 3, 1 gave us that. If you have graph paper, I'd strongly encourage you to use graph paper just to make sure that your graphs are more accurate and so you can easily tell what your vertices are.